is a fairly small but nevertheless very important tutorial on casting in Java. So in Java there's a bunch of numerical types. For example, we've got int, which let's say we have an integer value. We can use int to store it, and there's also like there's a short version of int which takes up less memory. I think int is actually 32 bytes, and short is I think 32 bits for int, and short is 16 bits. I think that's right, or 2 bytes. So let's say short value equals 55 or something. And there's also like a byte type, and byte can only store up to from minus 128 to plus 127. So a total of 256 different values if we include the 0. So let's say here byte value equals 20 or something. And there's also like a long, so long value equals, and that could be a really long number. And of course we've got floating point values. We've got float value, and this can have a point in it, equals something like this. And we've got a double value that has even greater precision. I can't remember how many the maximum values of this off the top of my head, but you can easily look them up. Let's say double value equals something like this. And if you do want to know the kind of maximum minimum values, oh, by the way, there's something that I wanted to show you here, which is that if you type a value with a point in it here, a decimal point, it has a double type somehow by default. And so when I try to assign a value with a floating point to a float value, I get an error, and it's going to say cannot convert from double to float. And one really simple way of dealing with that is just to put an F on the end of it, and that turns it into a float value. So it's useful to know. And if you wanted to know the maximum and minimum values for these types, you could look at the non-primitive versions of these. For example, double. This is the class version that has various methods, and that's got like a max value on it, for example. So, or I could say, like byte.max value. Let's just do a sysout on that so we can see sysout. And if I run that, it's 127. Now you can actually cast from one kind of numerical value to another. So if you have one kind of numerical value and you want to store it in a variable of a different type, you can use a cast. So I could say, for example, if I say like int value here equals long value, like that, and I save it, I'm going to get an error here because it's saying cannot convert from long to int. But in fact I often can convert from long to int, because if I look at this value here, that would fit in an integer type. It's a relatively small value. So I can say here int, you put the type that you want to cast to this type in round brackets before the type that you're casting from, and now it accepts it and it's fine. And if I do a sysout on int value, and let's just run this program here, you can see it's still got the right value in, because this value fits comfortably in an int. You can also cast from floating point values to int values or the other way. So let's say I have now I've got an int value there. Let's say double value equals int value, and let's save that. And in fact it's letting me do that without even a cast. But what's going to happen is it's just going to, of course, it's just going to put a 0.0 on the end of it, so it's converting comfortably to a double value. And you don't need a cast there, because you're not, in a sense, you're not changing the value you're not chopping anything off, or because here there's a potential complication that we'll look at in a second, where if I had a long value that was too big to fit into an integer type, because long is, I think it's 64 bits and int 32 bits, I think, then you could potentially have problems. So this kind of casting is a way of saying, look, I really know what I'm doing, I definitely want to do this, change it to an int. Whereas with this, there's less potential for stuff to go wrong, so Java will just do it for you, and you don't need a cast. And we can convert the other way as well. Let's say I want to say, supposing I have a double value, let's set double value back to, in fact let's use that float value there. So I've got a float set to 8834.3. If I say int value equals float value, now there's potential for something to go wrong. Well, not go wrong, but the thing is we're going to lose the stuff after the floating point, 0.3. Let's change it to actually 0.8 because for a reason that I'll explain in a minute. And Java wants to know that you really do want to chop off the end of this here. So you have to cast it, and I can put a cast here. I can cast from the float value to the int value, and then let's do a sys out here on int value. And if I run that, then I've got 8,834. And notice this is not rounding off, it's literally chopped the end of it off. If you wanted to round it, you'd have to use math.round. But so if you just do a cast, it's just going to cut the end off. Now, one last thing I want to say in this tutorial, which is that you have to be really careful trying to stuff an oversized type into a type that's not got enough memory to hold it. So byte value, as we've seen, the maximum value of a byte is 127. And let's try to let's say byte value here, and let's try to cast a value to a byte that's too big. So let's say 128. And I can literally type a number there as well. It doesn't have to be a variable. You can cast a number to an appropriate type. So an alternative syntax here, for example, would be, let's say, float value 2 equals 99.3. So that's a double value, so I need a cast. But instead of putting an F on the end, I could just put float here, and that will work just as well. Now here, so 127 is the maximum value of a byte, and I'm trying to put 128 into it. And let's just do a sys out here, and look what happens. So byte value there. And if I run that, it's going to minus 128, which is the minimum value of it. So it's kind of like it's wrapped around. So that extra 1 has pushed it around the circle, and it's gone kind of around the circle all the way to the minimum value that it can have. So you have to be really careful, and when you're typing this, when you're typing a cast, you're casting from one type to another, you're implicitly doing something that could go wrong, and you have to really carefully think, is this going to work? Have I got enough memory in the type that I'm casting to store the value that I'm casting from? Otherwise you'll get very strange results. Let's just put the following won't work. Well, it will work, but as we expect it to. And I'll just put a comment there. 1 to 8 is too big for a byte. Okay, and sometimes beginners in programming will try to cast from one completely different class to another, and you can't do that. This just works because these numerical types are all just storing numbers, but you can't cast like from a string to a I don't know, to a you can't cast from like a string to an integer. That's a good example, because often you've got an integer and you want to get a string from it, and you can't just put a cast in there because these are two completely different objects. You can't cast one from one to the other. If you want to convert from an integer to a string, you have to use toString, and if you want to convert from a string to an integer, you'll have to use integer.parseInt or something like that. So that's it for this tutorial, and in the next tutorial we're going to look at upcasting and downcasting. So we're going to build on this to look at the really important topic of under what circumstances you can actually convert from one object to a different kind of object, because there are some circumstances where you can do that as long as there's a child-parent relationship there. So that's it for this tutorial. I hope that's useful. Join me again next time.